We're back here in Building 9, this time talking with Zack Crues, who is the modeling and simulation lead. He is going to tell us about what's going on behind us here with the space exploration vehicle Mockup. Thanks so much for joining us, Zack.
It's my pleasure.
Okay, so tell us a little bit about modeling and simulation, what that means, and what it has to do with this test.
Well, the importance of modeling and simulation in this test is that we really can't be in deep space. We've never been there before, and so in order to set up an environment which we can get information about the next missions that we're going to go forward, we need to set that up in a digital environment or a computer environment that we can immerse the astronauts in. And so this is the space exploration vehicle mock-up that we have here.
This is where 2 people are living for 3 days.
That is correct. And we have that hooked up to a series of computers that are right behind it that drive a display in front. And what that does is it gives kind of a next generation Star Trek holodeck environment that they can go into, and they can fly the SEV, and they can get information about the performance of the space exploration vehicle, including how much mass it's going to have as far as propellant, to understand the operational environment that they're going to be working in around the asteroid, things that we have never done before. But we're taking the experiences that we had in human space flight for the shuttle program, for the space station program, for the Constellation program, and taking those technologies, specifically the models and sims that we have, and our operational experience, and merging those together and exploring the next steps in exploration for NASA.
Very interesting. And you've been doing this for different vehicles for a while, right?
Yes, I have. I've been involved in shuttle modeling and simulation, space station modeling and simulation, Constellation, and now I've got the pleasure of working on our next generation space exploration vehicle.
Definitely cool work. So I don't know how well people can see it. Behind us here, there's a projection screen that has a view of the asteroid, I guess.
That's correct.
And we're seeing the back of the space exploration vehicle cabin with the spacesuit hanging off of it. And on the front is the windows where they actually see what they're exploring.
That's correct. So we have a projector that you can actually see projecting an image that pertains to the view that the astronaut would see sitting in the seats. We have to tune it very specifically for where they are in the cabin and what they're looking at. And then we actually have a simulation that goes and reproduces the dynamics of the vehicle as they put in thruster commands, as they fly around the asteroid, that gives them the perspective, including the digital readouts on the control systems, so that they can understand how they want to go about flying and investigating an asteroid.
So as they simulate flying the rover around, even though we're not seeing it moving, the picture in the window is moving.
Right. So they think they're moving, even though it's a fixed base here. They think they're moving because every input they put into the system results in a change in the view out the screen. We have the same environment that we have here on the flat floor, we can also do in a big dome environment that we have over in Building 16 here at JSC.
Right, and we've taken the previous generations of the rover out to the field on wheels, but obviously wheels don't work on an asteroid.
Right, the difference is that when you're out in the field, you're really limited to 2 dimensions. There's a little bit of terrain, but here it's very much a 6-dimensional environment. And when I say that, that's because you can move anywhere around as well as turn around in attitudes. You can fly upside down, you can fly right side up, backwards, forwards, all of that.
All right, and that's what you do.
That is what I do.
Thank you so much. I really appreciate your time. I wish we could talk longer, but we're out of time.
So, anytime, thank you.
If you would like to find out more information, you can visit nasa.gov/desertrat.